March 7th, 1945. The west bank of the Rhine River near Wesel, Germany. American intelligence officers trace German machine gun positions through binoculars as a light rain falls over the churning waters. The distant rumble of artillery punctuates the night as 16 assault boats from the 5th Ranger Battalion are quietly unloaded from transport trucks. Within 15 minutes, the crossing operation ends. 7 Rangers wounded, 2 German pillboxes silenced. The official after-action report reads, "Enemy defences exhibit fatal fixed positioning. Our mobility advantage remains effective despite strong current." Technical officers confirm the finding. The new American M2 assault boats, fitted with Johnson outboard motors, traverse the Rhine faster than German commanders believed possible. Yet the American forces could still maneuver silently when needed. From March to April 1945, this duel, mobility versus fixed defences, defined the final phase of combat in the European theatre. It was a contest of tactical philosophy, technological adaptation, equipment reliability, and operational flexibility. Each side believed its approach could dominate the battlefield. Only one would prove adaptable enough to win the war. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. A supply sergeant of Kampfgruppe Wesel initials the morning situation report. The February frost still clings to the concrete bunker walls as engineers review defensive blueprints. Across the river, a battalion commander at Remagen pencils a new assault plan onto his tactical map. The Rhine crossings, as Allied commanders called them, represented a fundamental military challenge. Gone were the mobile battles of the earlier French campaign. In their place, a hardened defensive line, German engineers installing underwater obstacles and interlocking fields of fire from prepared positions. Intelligence reports indicated defensive depth exceeding 2,000 yards from the shoreline. A 15% improvement over previous German river defense doctrine. German officers quickly recognized the advantage. The fortifications felt substantial, more reassuring than their hastily abandoned positions in France. American planners had expected major bridging operations with heavy equipment. Early reconnaissance reports described lightweight craft being rejected as unsuitable. General Omar Bradley, commanding the 12th Army Group, warned of extensive preparation requirements in captured correspondence with Supreme Headquarters. He urged rapid development of specialized river crossing equipment to match the threat. The numbers told the story. Standard river crossing operations using M2 pontoon bridges required 5 hours to establish a battalion-sized bridgehead. The new American assault boat tactics achieved the same objective in less than 45 minutes. A division operations room summary from early March 1945 noted, "Enemy expects conventional crossing. Our forces achieve surprise through unorthodox methods." The tactical innovation compelled an emergency reassessment of German defensive positions. German engineers worked around the clock to adjust their Rhine fortifications. The river that had saved Germany from invasion in 1944 needed defences it did not yet have to remain an effective barrier in the spring of 1945. Engineers on both sides positioned their assets along riverbanks and in staging areas. At Fort Benning, technicians measured an M2 assault boat's stability curves while recording current resistance rates. At Cologne, German test staff photographed machine gun placement angles and new bunker geometries. Both armies anticipated conventional river assault operations. The field reports revealed unexpected tactical innovations instead. American trials officers recorded the 5th Rangers achieving crossing speeds of 7 minutes under simulated combat conditions. German test sheets showed their MG-42 machine guns requiring 9 minutes to fully reposition between firing sectors. The 2-minute difference seemed small on paper. In combat, it proved decisive. More critical was the equipment divergence. German defensive doctrine relied on pre-arranged fields of fire covering expected crossing points. The American rubber boat design allowed crossings at unexpected locations without revealing launch preparations. Ranger Captain William Henderson recorded in his field notes, Boats undetectable at 300 yards in darkness. Germans focus on bridge sites. Test engineer Hans Müller noted the German bunkers' limited traversal capacity, writing, "Fixed positions maintain superior firepower where targeted but cannot rapidly adjust to unexpected approaches." The element of surprise became an American tactical weapon. American Rangers used quick deployments from unmarked shorelines to bypass the most heavily defended sections. German gunners hesitated for the crucial seconds their weapons took to traverse, often deciding survival versus victory. Combat testing revealed another contrast. The German MG-42 delivered tremendous firepower through a narrow firing arc optimized for predetermined killing zones. The American M2 assault boats spread their crossing capabilities across broader river sections, supporting both combat insertions and logistics operations. American engineers prioritized flexibility and field adaptation. German designers pursued defensive perfection within predetermined engagement parameters. These philosophical differences would echo through every aspect of the final river battles. The fixed defensive line remained a German advantage. The element of surprise belonged to America. A Fort Bragg tally board, flipped to 340 Rangers river qualified this month across the training centers. A Wehrmacht quartermaster signed for a smaller ammunition allocation than his units had requested. Logistics capacity was reshaping river war as decisively as engineering prowess. America's equipment production network accelerated under wartime pressure. Rock Island Arsenal, operated by the War Department, reached monthly output of 450 M2 assault boats by early 1945. Johnson Motor Company's main facility at Waukegan contributed additional outboard engines despite material shortages. Germany, operating under catastrophic resource constraints, produced fewer than 120 reinforced defensive positions monthly across all sectors. Organization TOT's Rhine construction unit struggled with concrete shortages and skilled labor redeployment to other fronts. Cost differentials mirrored the strategic imbalance. American procurement records show $650 per M2 assault boat, including engine and equipment. German engineering documents list 4,800 Reichsmarks per hardened machine gun position, a ratio suggesting equivalent resource investment despite different monetary systems. Supreme Headquarters' weekly returns documented a 4-to-1 production advantage by March 1945. American staff planning papers tracked this numerical superiority across operational groups, yet combat effectiveness required more than factory output. German defensive positions achieved higher effectiveness rates, averaging 78% hit probability across frontline units. American forces struggled to maintain 66% accuracy during high-tempo river assault operations. German gunners fired more rounds per position, maximizing their numerical disadvantage. Erich Weber's Kampfgruppe Köln achieved 7-to-4 casualty ratios during initial defense operations against conventional bridging attempts. Post-battle reports credited superior fields of fire and interlocking defensive positions. American officers logged higher casualty rates due to exposure during river crossings and limited covering fire opportunities. By March 1945, both armies recognized the same strategic truth. Technical superiority alone could not overcome sustained numerical disadvantage. Conversely, numbers alone could not compensate for tactical gaps that decided individual engagements. Defensive dominance meant little if positions could not adapt quickly enough for mobility to matter. Fixed positions led on paper, but surprise still decided outcomes on the river. A formation of M2 boats assembled along the American-held riverbank as Ranger teams received final briefings. Kampfgruppe Wesel sentries waited in concrete bunkers. Searchlights powered down to conserve fuel while maintaining defensive readiness. Operation Varsity missions aimed to establish bridgeheads across the Rhine into German territory. American planners expected to leverage superior mobility and specialized training. The Wehrmacht expected to dictate engagement timing from prepared positions. Official combat records document 38 river crossing engagements between February and March, 1,945. American claims totaled 28 German positions neutralized. Ranger crossing losses reached 34 casualties across all causes, SAM, combat, accidents, and operational failures. 9th Infantry Division post-action analysis concluded, enemy cannot respond quickly enough. Mobility superiority decisive. The Rangers' crossing speed allowed American formations to position themselves beyond primary defensive belts, then choose engagement, timing, and duration. Technical factors explained the tactical imbalance. The Johnson outboard motors and lightweight hull design improved crossing performance under combat conditions. American forces exploited this advantage by maintaining multiple crossing points between prepared German defensive sectors. The German bunker design yielded devastating, steady fire within predetermined sectors below 800 yards. German commanders who forced combat into their prepared killing zones could achieve overwhelming firepower advantage. Yet ammunition limitations prevented extended engagements when American forces bypassed primary defensive positions. Kampfgruppe Wesel situation report noted, Americans avoid expected crossing points, flank security insufficient against mobile assault. German defensive doctrine emphasized predetermined fields of fire over rapid repositioning capability. American assault profiles adjusted throughout the campaign. Multiple simultaneous crossings thinned defensive coverage, reducing effective response. German commanders timed their illumination to catch crossing teams during peak vulnerability windows. Combat camera analysis revealed engagement patterns. German gunners initiated firing from prepared positions, used interlocking fields to suppress expected landing zones, then faced flanking attacks before gun crews could reposition. American teams who landed at predetermined points often found themselves at a firepower disadvantage. Dominance alternated with the tactical situation, not the casualty counts. Neither force achieved decisive control over all crossing zones. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Metallurgists examined rubber compound samples under microscopes, while engineers drafted service bulletins revising maintenance procedures. The River War had become a contest of material science as much as tactical doctrine. Designers on both sides had aimed for equivalent reliability standards. Material shortages forced German manufacturers to substitute lower-grade concrete with unknown durability characteristics. American industry maintained access to strategic materials through robust supply networks. The M2 assault boat employed synthetic rubber and aircraft-grade aluminum designed for 120 crossing service life. Manufacturing quality control maintained consistent performance across production runs. Technical bulletins extended recommended maintenance intervals based on field experience and improved waterproofing compounds. German engineering documentation noted substitute reinforcement materials, reducing expected defensive position lifespan from 180 days to 90 days in some frontline sectors. The MG-42 design relied on precision machining and high-quality steel, increasingly difficult to source under wartime constraints. A Fort Benning test card recorded, revised hull coating yields plus 30% durability on abrasion test. Incremental improvements accumulated through methodical engineering development. American designers pursued durability alongside performance enhancement. German engineers answered with concrete thickness increases and additional steel reinforcement. The modification added approximately 45% structural integrity to machine gun nests above the waterline, extending defensive capability. Implementation required additional weight, complex construction requirements, and specialized equipment. Wehrmacht engineering reports documented the trade-offs. Enhanced defensive capability came at the cost of reduced construction speed, increased material demands, and higher skilled labor requirements. Only select sectors received fully reinforced positions. American production philosophy emphasized standardization and field repairability. U.S. Army technical publications simplified maintenance procedures and parts interchangeability. Boat repair teams could patch damaged craft using common tools and procedures. German design pursued maximum defensive strength within tightening resource constraints. Each technical advantage required specialized materials, engineering expertise, or construction equipment that strained industrial capacity. Defensive improvements often reduced overall position quantities. Manufacturing statistics revealed the strategic implications. America gained operational flexibility and sustained crossing capability. Germany achieved localized defensive superiority at the expense of comprehensive coverage. Every extra 10% in defensive strength cost tons of concrete and steel that Germany could barely afford to produce. Clipboards in briefing tents across Europe displayed evolving tactical diagrams. The Army's traditional large-scale bridgehead operations gave way to German-inspired dispersed resistance pockets. Continental bases briefed night infiltration techniques and silent paddle approaches. Wehrmacht defensive doctrine had evolved from earlier Eastern Front experience. The hardened bunker system and interlocking fields of fire emphasized mutual support and predetermined engagement areas. German commanders maintained disciplined fire control that maximized ammunition effectiveness while preserving concealment. U.S. Army Engineer Corps still employed conventional bridging operations derived from peacetime river crossing exercises. These methods required substantial preparation and telegraphed intentions to defending forces. Engineers concentrated on bridge establishment rather than tactical surprise. Colonel James Gavin conducted tactical trials at training sites throughout winter 1945. His units experimented with rubber boat crossing concepts adapted for combat insertion requirements. Results showed improved survival rates and engagement effectiveness. By spring, combat loss analysis credited 30% improvement in exchange ratios following tactical adaptation. American units adopted dispersed crossings with specialized infiltration teams. The traditional combat engineer approach expanded to incorporate Ranger-developed techniques. German officer Franz Liebholz noted in his diary, "Americans no longer follow expected doctrine. River defense requires more flexible response." Wehrmacht commanders found American crossing operations increasingly difficult to predict and counter during initial phases. M2 assault boat testing improved hull thickness at the expense of weight performance. Modified craft traded ultimate speed for enhanced durability under combat conditions. The change better matched probable operational requirements along the Rhine's challenging currents. Radio procedure, modifications refined coordination protocols. American commanders developed standardized terminology for crossing sectors and defensive position identification. Clear communication enabled rapid adjustments during operation development. Training Command integrated multiple crossing techniques into basic combat engineer instruction. New units learned rubber boat operations alongside traditional bridging methods. Engineer battalions emphasized tactical flexibility and surprise over comprehensive preparation. Tactical innovation narrowed the defensive gap between opposing forces. American mobility advantages converted more frequently into successful lodgements. The U.S. Army borrowed pages from the Commando playbook and began writing new tactical chapters. Transport crews loaded M2 assault boats onto GMC trucks as the American forces approached the Rhine. At Wesel airfield, a maintenance worker checked ammunition belts, while German sentries peered into the darkness. Ranger teams prepared under camouflage nets across forward assembly areas. Operation Plunder tested both military approaches under extreme combat conditions. 5th Ranger Battalion and specialized engineer teams arrived via truck convoy missions. Opposing them, German Kampfgruppe Dinslaken and local Volkssturm units manned defensive positions along likely crossing points. 2nd Battalion combat returns documented 23 German positions neutralized against 27 Ranger casualties during the initial crossing period. These figures reflected tactical parity, despite attacking against prepared defenses with limited supporting fire. Environmental conditions erased theoretical advantages. River currents reduced both boat types' crossing efficiency by approximately 15%. Wave action shortened operational intervals from normal 80 crossings to 35 crossings under combat conditions. Nighttime operations prevented accurate defensive fire but reduced coordination effectiveness. American after-action reports noted, boats handling, sluggish, Darkness essential despite coordination challenges. German Kampfgruppe modifications reinforced secondary defensive positions to compensate for assault boat mobility advantages. Operational challenges dominated the campaign. Forward American positions operated under constant observation while managing ammunition resupply challenges. Rhine crossing points struggled with current fluctuation affecting landing zone accuracy and equipment retrieval systems. Boat motor modifications addressed reliability problems. Both military forces required enhanced maintenance schedules and modified equipment arrangements. These changes added logistical complexity while improving operational reliability under combat conditions. Kampfgruppe Dinslaken logs recorded repeated ammunition resupply delays. Defensive operations shifted to selective engagement periods when supply limitations reduced operational effectiveness. Full defensive activation became operationally prohibitive, except during major crossing attempts. Combat tactics adapted to resource constraints. Commanders avoided sustained high-volume fire that caused rapid ammunition depletion. Fire discipline emphasized concentrated bursts over sustained suppression in the defensive envelope. Along the Rhine's historic waters and fortified banks, neither approach dominated through technical superiority. Logistical capability and tactical adaptation determined operational success rates more than equipment performance. Both soldiers and machines fought through conditions that tested endurance as much as combat effectiveness. A small rubber patch held up during a technical briefing at Fort Bragg. Test pilots at Fort Benning prepared to paddle their boats across simulated currents while engineers monitored hull performance. The small repair kit would eliminate a tactical vulnerability that had cost American lives for several weeks. Engineer Captain Margaret Maggie Dornberger's M2R15 rubber compound addressed the assault boat's puncture vulnerability problem. Standard rubber design suffered catastrophic failure when struck by defensive fire or underwater obstacles. German defensive positions had incorporated sharpened stakes and concealed metal fragments since January. American Rangers who encountered these hazards often found themselves stranded in mid-current. Benning test operations confirmed the modification's effectiveness. Post-installation trials permitted sustained operation despite simulated puncture damage. Test log entries recorded no loss of buoyancy observed under simulated battle damage. The reinforced rubber maintained structural integrity while preventing progressive failure. Installation across operational units proceeded rapidly through March 1945. Battalion diaries noted improved survival capabilities and reduced abandonment rates. The simple modification restored tactical reliability in the contested crossing zones. Combat validation came during Operation Varsity, the Rhine crossing of March 24, 1945. 32 boats of Ranger and specialized engineer units faced 19 hardened defensive positions across the river near Wesel. Operational losses totaled 24 Allied casualties against 37 German. While still challenging, the exchange ratio represented significant improvement over earlier operations. Wehrmacht post-action reports noted enemy boats sustained damage without sinking. Crossing teams maintain momentum despite defensive fire. American battalion operational record books documented the tactical change. Boats stable despite multiple punctures. Teams maintain forward progress. Rangers who previously hesitated during exposed crossings now pressed attacks through defended sectors. The rubber compound modification eliminated a significant German tactical advantage. Combined with improved motor mounts and reinforced gunwales, the changes restored crossing capability in contested zones. A small patch of synthetic rubber closed a large tactical gap. American engineering pragmatism had solved through simplicity what German design achieved through excessive fortification. A factory-fresh M2 assault boat ran up to rated capacity, while technicians at Aberdeen Proving Ground prepared a captured German defensive position for comprehensive trials. American engineers had refined their assault craft design to its material and functional limits. Any further improvement would require fundamental redesign rather than incremental development. The M2 variant represented the assault boat's peak evolution. The Johnson 4 HP engine produced reliable propulsion at rated settings. Maximum crossing speed reached 8 miles per hour in calm water. The reinforced hull carried 8 fully equipped Rangers, providing substantial insertion capability in a lightweight package. American designers expected balanced performance across all operational conditions. Field reports began requesting additional armor protection to match the German MG-42's effective range. The weight penalty of additional protection would compromise the M2's speed advantage. American evaluation at Aberdeen revealed the design strengths and limitations. Test notes recorded responsive handling, stability marginal at maximum capacity. The craft handled predictably throughout its operational envelope, but demonstrated reduced maneuverability above 75% capacity. Comparative survivability analysis favored the German defensive position. Reinforced concrete with interlocking fields of fire delivered greater protection than the Rangers' exposed crossing approach. American insertion tactics achieved higher surprise value and positional flexibility per unit. Combat film analysis confirmed field observations. American teams required more deceptive maneuvers to achieve equivalent insertion success. The M2's superior crossing speed provided mobility advantage, but survivability limitations affected operational success rates. Structural analysis revealed design optimization limits. The lightweight hull maximized transport efficiency while constraining protection potential for additional defensive measures. Engine power requirements dictated weight distribution that affected stability calculations. Load capacity had reached equilibrium between performance and capability. Additional armor protection would degrade speed. Larger engine would reduce passenger capacity. Enhanced structural reinforcement would compromise transportability. Aberdeen's final assessment noted the M2's elegant balance between competing requirements. American engineering had achieved near-optimal configuration within original design parameters. Further development required accepting trade-offs that would compromise existing advantages. The assault boat design had reached its evolutionary peak. Any additional capability would add weight faster than performance improvements could compensate. American designers faced a fundamental fork in development priorities. Radio networks filled with varsity call signs as Operation Plunder commenced. M2 assault boats with reinforced hulls launched from concealed positions, while German defensive sectors and Volkssturm units responded from prepared fortifications. The German command expected to repeat their fixed defense advantage tactics that had proven successful during previous operations. American forces arrived with puncture-resistant hulls, improved motors, and specialized training that enhanced crossing performance. River combat developed throughout the night hours as both armies committed available strength. Wehrmacht defenders attempted their traditional fixed-position defense, followed by concentrated fire. American formations maintained cohesion and pressed through defensive zones previously impassable. Combat results documented a tactical shift. Total losses reached 24 Allied casualties versus 37 German, still challenging, but representing significant improvement over comparable operations. The qualitative change appeared in survivability, capabilities below 500 yards engagement range. M2 assault boats no longer failed catastrophically during crossing operations. Teams maintained forward progress through defensive fire, eliminating the crucial delay seconds German positions had exploited since February. Captain Dornberger's rubber compound had closed a fundamental tactical gap. Wehrmacht after-action reports noted, enemy formations exhibit improved damage resistance. German commanders found American crossing operations more persistent in execution and more aggressive in approach vectors. Traditional defensive concentrations proved less reliable. Reinforced hull M2 modifications traded ultimate speed for enhanced survivability under fire. The change better matched probable combat conditions along the heavily defended Rhine while improving operational reliability under adverse conditions. High-strength synthetic rubber provided additional durability across the boat's operational range. Military-grade compounds enabled higher resistance settings without catastrophic failure damage. Hull modifications supported the increased durability demands. American battalion operational record books recorded. Boats stable despite multiple punctures. Teams maintain forward progress. Tactical reliability had replaced German defensive superiority in the sectors where most crossing operations occurred. Combined modifications, rubber compound, hull reinforcement, and training improvements, RESOTE, eliminated the systematic vulnerabilities that had constrained American tactics. A handful of material changes rewrote weeks of river combat doctrine. The defensive advantage monopoly ended. German and American forces now competed on equal terms across most of the operational envelope. Production ledgers closed for March, as group operations officers drew up replacement personnel and equipment requests. Industrial capacity was determining Rhine crossing outcomes as decisively as individual combat skill or equipment performance. German defensive position construction during the critical period totaled approximately 430 hardened positions across all river sectors. Organization. TOT facilities at Cologne and Düsseldorf operated under catastrophic resource constraints that limited weekly output. Skilled labor shortages affected construction quality and completion schedules. American M2 assault boat production reached 2,478 craft during the same period. Rock Island Arsenal, Johnson Motor Company, and other manufacturers sustained output despite material challenges and competing priorities. Commonwealth production supplemented American facilities. Strategic implications emerged at corps level. By April 1945, the American forces fielded approximately 15 operational Ranger and specialized engineer companies on the Western Front. The Wehrmacht sustained only 7 comparable defensive sectors across all Rhine crossings. Numerical advantage enabled sustained operations that German forces could not match. Combat losses reflected the production differential. Approximately 110 German defensive positions were neutralized due to all causes: combat, abandonment, and operational attrition. M2 assault boat losses totaled 186 craft, but American industry replaced losses at a 5-to-1 ratio against German construction capacity. Wehrmacht quartermaster reports documented concrete and steel bottlenecks that constrained defensive preparations. Strategic material shortages forced substitutions that reduced durability and effectiveness. Maintenance intervals shortened as quality control declined under production pressure. Army Group B weekly strength returns showed serviceable to total defensive position ratios declining with increased Allied pressure. Replacement materials arrived slower than combat consumption, constraining unit effectiveness and defensive depth. Strategic weakness accumulated throughout March 1945. Allied staff planning papers tracked numerical superiority across operational sectors. Represented only one demand on German defensive resources: Eastern Front, Italian Front, and strategic reserve requirements dispersed available strength across multiple combat zones. American crossings concentrated against specific objectives, while German forces dispersed to meet multiple threats. Strategic presence persisted, where industrial capacity sustained it, while numerical inferiority forced defensive reactions. Combat parity in individual engagements became inequality on operational rosters. Factory output decided long-term outcomes before tactical superiority could achieve decisive results. The River War's verdict appeared first in production ledgers, then in operational strength. A line chief signed equipment acceptance paperwork for an M4 assault bridge, while Wehrmacht engineers tightened defensive perimeter around a Rhine crossing point. Both armies had escalated their river operations. Pursuing enhanced performance through increased complexity and scope, Germany introduced the West Wall reinforcement program with added concrete thickness and MG-42 twin mounts. Defensive integrity increased through 25% greater material density, improving survivability performance. Structural reinforcement supported higher ammunition loads and increased crew protection. German commanders reported better sustained fire capability, but noted reduced construction rates. The West Wall gained defensive strength faster than construction speed, degrading the coverage that had characterized earlier defensive lines. Sector coverage suffered at extended defensive perimeters, while construction rates declined throughout the theater. Intelligence reports documented German engineer complaints about reduced material quality and increased failure rates. West Wall's reinforced peak had given way to fragmented defensive gaps. American response came through the M4 assault bridge fitted with the Coleman MF1 pontoon system. Crossing capacity reached 40 tons at rated settings, restoring and exceeding bridge capacity above tactical crossing points. Combat trials confirmed the M4 superiority at operational scale. The pontoon system maintained structural integrity through higher load capacity than German defensive fire could interdict. American engineers regained the strategic advantage that had been threatened by the West Wall reinforcement. Aberdeen summary reports concluded, M4 performance closes strategic gap. The new variant matched German defensive integrity while maintaining superior mobility performance. American industry had successfully escalated the capability competition. Design philosophy differences became apparent through development paths. The American bridge family evolved through systematic component upgrades that maintained field compatibility. Production lines adapted to new variants without fundamental retooling. German development added complexity to existing designs rather than pursuing comprehensive solutions. The West Wall carried forward earlier Siegfried Line limitations while attempting to enhance capability through material increases. By April 1945, the German defensive design had reached material limits. Further development required accepting compromises that negated existing advantages. American design retained development potential through modular improvements. West Wall's reinforced peak had established German defensive superiority for several weeks. The scattered implementation represented the beginning of German defensive obsolescence in the face of systematic American industrial development. A test team photographed a captured German defensive position, while an Aberdeen report binder opened to comparative performance graphs. Wartime combat had generated numerous claims about defensive superiority, but technical evaluation would separate myth from measured reality. Post-operation technical assessment confirmed near equal design balance between the M2 assault boat and German defensive positions. Each approach demonstrated specific advantages within particular engagement zones, with overall effectiveness determined by tactical employment rather than absolute technical superiority. Aberdeen conclusion stated, combat effectiveness determined by tactical use, technical balance near equal. The American approach maintained stronger mobility and insertion performance, while suffering weaker defensive protection. The German position exhibited superior firepower and protective characteristics alongside greater ammunition capacity, but demonstrated restricted flexibility and higher resource requirements. Comparative operational characteristics revealed design philosophy differences. Aberdeen notes, M2 provides multiple approach options, German positions optimized for predetermined sectors. American design prioritized mobility and tactical flexibility, while German engineering pursued maximum protection within resource constraints. Development potential had distinguished the competing approaches. American evolution reached the M4 bridge variant by war's end, incorporating increasingly capable components and enhanced capacity. The German defensive lineage ended with the scattered West Wall reinforcement, outpaced by resource depletion and construction limitations. American iterative upgrade paths scaled with industrial capacity. Production lines accommodated new variants without disrupting output rates. Modular design enabled component swaps, power updates, and equipment modifications throughout the campaign. German design refinement within narrow parameters had achieved elegant solutions to specific requirements. However, fundamental resource constraints limited development potential as performance demands increased. Material demands exceeded construction capacity, degrading original advantages. By April 1945, industrial capacity had decided the river crossing competition as decisively as tactical efficiency. America's ability to produce sufficient quantities of competitive equipment overwhelmed German technical sophistication and defensive skill. Strategic bombing had eliminated German production advantages, while Allied resources sustained American development. Defensive strength alone could not overcome systematic numerical disadvantage, combined with resource constraints. The crossing duel between American mobility and German fortification had tested design philosophy, industrial strategy, and national will. One approach moved faster, the other defended stronger. Only one nation possessed the industrial base to build enough competitive equipment quickly enough to impose its tactical preferences on the war's outcome. The Rhine crossing reports landed on General Omar Bradley's desk as the final phase of the European campaign accelerated. His commanders reported successful lodgements across sectors previously considered impassable. Technical intelligence summaries documented the decisive role of unheralded equipment modifications in enabling operational success. Captured German assessment documents revealed enemy surprise at American crossing capabilities. What Berlin had dismissed as flimsy rubber boats had outmaneuvered their concrete fortifications through unexpected technical and tactical innovations. The Rangers had accomplished in minutes what conventional doctrine claimed would require hours. Preliminary planning for the Pacific Theater incorporated these river crossing lessons into amphibious doctrine. The same mobility advantages that defeated German defenses would apply against Japanese island fortifications. Technical staff recommended expanding rubber boat production while incorporating the latest hull compounds and propulsion systems. War Department production orders increased monthly M2 boat allocations by 35%. Johnson Motor Company received priority material designations for outboard engine components. Combat experience validation had elevated an underestimated technology into strategic significance. What started as a limited Ranger technique had evolved into mainstream doctrine. Bradley's after-action review highlighted the broader strategic lesson. American industrial capacity had translated initial technical parity into overwhelming numerical advantage within months. Combat effectiveness ratios remained comparable between American and German equipment throughout the campaign. The decisive factor emerged from production statistics rather than performance characteristics. By March 1945, American forces deployed approximately 12 boats for every German defensive position along the Rhine. This quantitative advantage enabled multiple simultaneous crossings that overwhelmed defensive coverage. Technical stalemate became operational victory through production dominance. Bradley's memorandum to General Eisenhower emphasized these conclusions. The Supreme Commander incorporated these findings into strategic planning for final operations. Traditional doctrine had emphasized massive bridging operations, requiring extensive preparation and logistical support. The Ranger experience demonstrated that lightweight, rapidly deployable crossing equipment could achieve comparable results with minimal preparation. Eisenhower's operations director revised crossing timelines based on the new calculations. Units previously scheduled for later phases received priority M2 boat allocations and accelerated training schedules. The entire Western Advance timeline compressed by approximately 15 days through incorporation of the new techniques. This acceleration rippled through strategic planning at all levels. Supply depots repositioned forward dumps to support the increased operational tempo. Medical units revised casualty projections based on improved crossing survivability data. Intelligence staff updated enemy defense assessments, incorporating the reduced effectiveness of fixed positions against multiple simultaneous crossings. The rubber boat revolution extended beyond tactical innovation into operational art. German command recognized the strategic implications too late to effectively counter them. Western Front intelligence reports documented frantic efforts to reinforce river defenses through March 1945. Concrete allocations shifted from Atlantic Wall maintenance to Rhine defensive positions. Additional MG-42 production diverted from Eastern Front requirements. These resource reallocations came too late to significantly affect crossing operations. American forces had already established multiple bridgeheads before additional defenses could be completed. Wehrmacht General Staff assessments acknowledged the fundamental miscalculation. They had dismissed lightweight assault boats as tactically insignificant compared to formal bridging operations. This assumption created critical defensive gaps that American Rangers exploited through specialized training and equipment modifications. The technical underestimation became a strategic vulnerability that accelerated Germany's final defeat. By April 1945, The rubber boat crossing techniques had entered standard American doctrine. Engineer battalions incorporated Ranger-developed methods alongside traditional bridging operations. Training schools revised curriculum to emphasize multiple tactical crossing options suited to different operational requirements. Technical manuals updated maintenance and repair procedures based on combat experience. The M2 assault boat transitioned from specialized equipment to standard issue. What began as an experimental technique had evolved into established doctrine through battlefield validation. The technical revolution spread throughout the Allied forces. British commandos adopted similar equipment and methods for special operations. French river crossing units incorporated the puncture-resistant compounds into their assault craft. Even Soviet forces received technical information about the rubber boat modifications through Lend-Lease channels. A tactical innovation born of necessity became an international standard through demonstrated effectiveness. Rangers who participated in the earliest Rhine crossings received little formal recognition. Their operations appeared as brief mentions in official histories focused on larger bridging achievements. The rubber boat revolution occurred with minimal fanfare despite its strategic impact. Captain Dornberger's rubber compound modification received a technical patent after the war, but attracted little attention outside specialist circles. The men who crossed the Rhine in 15 minutes remained largely anonymous within the larger narrative of Allied victory. Their achievement demonstrated how seemingly minor technical innovations could produce strategic effects when combined with tactical flexibility and industrial capacity. German defenders who once laughed at flimsy rubber boats learned this lesson too late to alter the war's outcome. The M2 assault boat and Ranger crossing techniques represented a quintessentially American approach to military problems. Rather than matching German defensive strength directly through equivalent fortification, American forces emphasized mobility, surprise, and numerical superiority. Technical adequacy, supported by overwhelming production, created strategic advantage despite tactical parity. This approach reflected broader American industrial strategy throughout World War II. From tanks to aircraft to naval vessels, American production emphasized standardization, reliability, and volume over technical sophistication. When combined with tactical adaptation and operational flexibility, this approach generated unstoppable momentum on the battlefield. The Rangers' rubber boat crossings demonstrated this principle in microcosm. Their boats were technically adequate rather than superior. Their training emphasized practical effectiveness rather than theoretical perfection. Their tactics exploited American industrial advantages while minimizing exposure to German defensive strengths. This pragmatic combination proved more decisive than any single technical advantage could have achieved. The lesson echoed through post-war military development across all services. Technical sophistication alone could not overcome the combined effects of industrial capacity, tactical flexibility, and operational momentum. The M2 assault boat and German defensive positions represented the pinnacle of river warfare design as World War II entered its decisive phase. Their Rhine confrontations demonstrated that technical excellence alone could not determine strategic outcomes when industrial capacity and operational flexibility entered the equation. Both approaches achieved remarkable performance within their design parameters. German engineering produced defensive positions optimized for predetermined engagement zones and sustained firepower. American design emphasized mobility and tactical flexibility. Combat effectiveness depended on tactical employment rather than absolute technical superiority. Industrial strategy ultimately decided the competition. America's production philosophy of systematic development and numerical superiority overwhelmed German technical refinement operating under resource constraints. Quality could not compensate for quantity when the quality gap narrowed through iterative improvement. The soldiers who fought on both sides demonstrated exceptional skill and courage regardless of nationality. Their individual engagements along Europe's historic river tested human limits alongside equipment performance. Respect for their sacrifice transcends the technical debate over tactical superiority. Historical memory preserves both the technological achievement and human cost of this river-crossing competition. A veteran Ranger lieutenant examined his combat decoration while seated in a Pennsylvania living room, 1976. His grandchildren gathered around as he unfolded a faded map of the Rhine crossing points. They said it couldn't be done, not without bridges and artillery preparation, he explained. But we crossed in 15 minutes while they were still waiting for the big assault. Across the Atlantic, a retired German engineer opened his wartime journal, pencil notations still clearly marking defensive position specifications. His technical drawings revealed the elegant simplicity of interlocking fields of fire that had seemed impenetrable on paper. "We built walls of steel and concrete," he told his son. "They found the gaps with rubber and courage." Both men had participated in a military revolution that transformed river warfare doctrine for generations. Their opposing approaches, HCUs, fixed defenses versus mobility, continued to influence military thinking long after the war ended. American amphibious doctrine incorporated the lessons of rubber boat operations into post-war planning. German defensive concepts evolved into NATO forward defense strategies during the Cold War. Technical manuals at Fort Belvoir still referenced the M2 assault boat's rubber compound as a standard for durability under combat conditions. Warsaw Pact defensive doctrine emphasized dispersed positions rather than concentrated fortifications, acknowledging the vulnerability demonstrated along the Rhine. The operational lessons outlived the equipment that generated them. Military historians traced the Rhine crossing's influence through subsequent conflicts. The Korean War's Incheon landing incorporated rapid deployment concepts first demonstrated by Ranger teams. Vietnam riverine operations utilized direct descendants of the M2 design. The technical lineage continued through Desert Storm and beyond, though few recognized its wartime origins. Pentagon archives preserved the technical drawings for Miss Dornberger's rubber compound, filed alongside more celebrated innovations like proximity fuses and radar systems. Her modest modification had saved countless lives during the Rhine crossings, yet received minimal recognition in official histories. Like many wartime innovations, its significance emerged primarily through operational impact rather than dramatic breakthroughs. By the 1950 seconds, the lessons of the Rhine crossings had been incorporated into standard American doctrine. The Army Field Manual for River Crossing Operations codified the tactics first developed by Ranger teams operating experimental equipment. Technical specifications, standardized rubber compounds, and hull reinforcements developed through combat experience. Training centers at Fort Benning incorporated river crossing scenarios based directly on Rhine operations. The Army's institutional memory preserved the technical and tactical innovations while gradually forgetting their origins. What began as desperate improvisation evolved into established procedure through combat validation. Veterans of the Rhine crossings rarely spoke about their experiences during the immediate post-war years. Like many combat soldiers, they focused on rebuilding civilian lives rather than recounting military achievements. Only decades later, as aging veterans faced mortality, did many begin sharing their stories with families and historians. A Ranger reunion in 1985 brought together surviving members of the 5th Battalion. Grey-haired men who once paddled rubber boats across German machine gun fire exchanged memories in a hotel conference room. Their conversations revealed how technical details remained vivid 40 years later. The distinctive sound of outboard motors at reduced throttle, the feel of reinforced rubber under tension, the weight distribution calculations that determined survival. "We crossed where they didn't expect us," explained former Staff Sergeant William Harker. "That boat design let us put men exactly where they needed to be, not where the Germans wanted us to land." His explanation captured the essential technical advantage that transformed tactical options. The M2's design flexibility enabled operational choices that conventional bridging equipment could not match. Former Captain James Randall added another perspective. "Intelligence told us which defensive positions had substitute concrete that wouldn't stand up to concentrated fire. We targeted those sectors first." His observation highlighted how American intelligence incorporated technical analysis into operational planning. Material science influenced target selection as significantly as tactical considerations. These veterans' recollections offered insights absent from official histories. They described how technical modifications affected operational decisions in ways official reports never captured. The reinforced rubber compound changed how teams selected crossing points, improved outboard reliability, influenced how far upstream units would launch to compensate for drift. These technical details translated directly into tactical options that shaped engagement outcomes. Victory emerged, not from dramatic technological breakthroughs, but from incremental improvements that expanded operational possibilities. The accumulated effect of minor modifications ultimately proved more decisive than any single innovation. As the veterans aged, historians began systematically recording their experiences through oral history projects. These interviews revealed how technical details influenced individual decisions during combat operations. Former Private First Class Michael Donovan described how his team modified their boat's gunwales with additional reinforcement after observing damage patterns from earlier crossings. "We added a second layer where the bullets usually hit," he explained. "Didn't stop everything, but gave us better odds of completing the crossing before taking critical damage." His improvised modification represented hundreds of similar adaptations that collectively improved survival rates across operations. These field modifications rarely appeared in official technical documentation but significantly influenced operational outcomes. Soldiers adapted standardized equipment to specific tactical requirements based on combat experience. This continuous battlefield innovation complemented formal engineering improvements developed through institutional channels. Technical historians examining German defensive preparations documented similar improvisation on the opposing side. Surviving engineering reports revealed how German commanders adapted to material shortages through tactical repositioning. When concrete quality declined due to resource constraints, defensive positions shifted to incorporate natural terrain features that compensated for structural weaknesses. "We positioned MG-42s to cover approach vectors rather than specific landing zones," explained a former Wehrmacht engineer in post-war interviews. This allowed flexible response with fewer fixed positions. His approach represented tactical adaptation to technical limitations, i.e., German forces adjusting operational concepts to match available resources. These opposing adaptations reflected fundamentally different approaches to the same operational problem. American forces emphasized equipment mobility and tactical flexibility, supported by industrial capacity. German defenders maximized fixed position effectiveness within severe resource constraints. The technical competition reflected broader strategic realities facing both nations during the war's final phase. By the 1992nd, declassified documents revealed the strategic significance of the Rhine crossings within overall Allied planning. What appeared as isolated tactical engagements actually represented coordinated efforts to accelerate the German collapse through psychological as well as military pressure. The rubber boat operations demonstrated Allied capability to cross natural barriers at will, undermining German confidence in their defensive strategy. Supreme Headquarters Allied Expeditionary Force, SHAEF, planning documents revealed how technical assessment of crossing capabilities influenced operational timelines. General Eisenhower accelerated the final offensive schedule based partly on demonstrated Ranger crossing performance during initial operations. Technical capability directly affected strategic decision-making at the highest command level. The psychological impact extended beyond military considerations into civilian morale effects. German civilian accounts described the psychological shock when American forces appeared in areas previously considered safely behind the Rhine barrier. The swift crossing operations contradicted propaganda assertions about impenetrable defenses and hastened civilian recognition of inevitable defeat. Intelligence assessments tracked declining German military morale following successful Allied crossings at unexpected points. The technical demonstration that no natural barrier could prevent Allied advance contributed to accelerating surrender decisions in some sectors. Equipment capabilities translated directly into psychological effects that hastened the war's conclusion. The Rhine crossings represented a perfect case study in how seemingly minor technical innovations could produce strategic effects through operational application. The reinforced rubber compound, improved outboard motors, and modified hull designs individually represented modest improvements. Collectively, they enabled operational capabilities that transformed the campaign's timeline and outcome. This relationship between technical capability and strategic effect became a central focus of post-war military education. War colleges incorporated Rhine crossing case studies into curriculum, examining how technological advantages translate into operational options and strategic outcomes. The rubber boat revolution provided a textbook example of this relationship accessible to officers at all levels. The U.S. Army's Command and General Staff College at Fort Leavenworth dedicated a permanent exhibit to the Rhine crossings in Inrolt, their tactical museum. The display juxtaposed an M2 assault boat against a reconstructed German defensive position, visually representing the competing approaches. Technical specifications accompanied the exhibit, highlighting how specific modifications affected operational performance. Military students studied how the rubber compound's development addressed a critical vulnerability in earlier operations. They analyzed how this technical modification expanded tactical options available to field commanders. The case study demonstrated how engineering solutions enabled operational flexibility that ultimately produced strategic advantage. This educational emphasis ensured the Rhine crossing lessons influenced military thinking long after the equipment itself became obsolete. The conceptual relationship between technical capability and operational options transcended specific technologies to inform broader military theory. Modern amphibious doctrine incorporated the fundamental principles demonstrated during those March 1945 operations. By the 21st century, the technical details of the Rhine crossings had largely faded from public memory. Few recognized how rubber compounds and outboard motors had influenced European history during those crucial weeks. The technical revolution occurred without dramatic breakthroughs that captured public imagination, despite its operational significance. Military professionals continued studying these operations for their enduring lessons about the relationship between technical capability and tactical options. The fundamental principle, SAA, that seemingly minor modifications could transform operational possibilities, remained relevant across technological generations. Modern force development incorporated this understanding into equipment, design, and procurement decisions. The veterans who participated in these crossings gradually passed into history, taking first-hand knowledge with them. Archival records preserved technical specifications and after-action reports, but could not capture the intuitive understanding that informed field decisions. Historical accounts increasingly relied on documentary evidence rather than personal recollection. Military museums preserved examples of the equipment that enabled these operations. The M2 assault boat occupied display space alongside more celebrated technologies like the atomic bomb and radar systems. Few visitors recognized its historical significance compared to more dramatic innovations, yet its operational impact arguably exceeded many better-known technologies. The technical revolution that enabled the Rhine crossings demonstrated a fundamental truth about military technology. Evolutionary improvements often produce greater operational impact than revolutionary breakthroughs. The reinforced rubber compound represented incremental improvement rather than revolutionary innovation, yet its operational effect transformed campaign timelines and outcomes. This principle continued influencing military procurement and development decisions long after World War II ended. Technical specifications increasingly emphasized reliability, maintainability, and operational flexibility rather than theoretical performance maximums. The practical lessons of combat experience shaped development priorities across service branches. The Rhine crossings exemplified the quintessentially American approach to military problems that emerged during World War II. Rather than pursuing theoretical perfection, American forces emphasized practical effectiveness, supported by overwhelming production capacity. Technical adequacy, combined with operational flexibility and industrial volume, proved more decisive than technological superiority alone. This approach reflected broader American industrial strategy throughout the conflict. From tanks to aircraft to naval vessels, American production emphasized standardization, reliability, and volume over technical sophistication. When, combined with tactical adaptation and operational flexibility, this approach generated unstoppable momentum on the battlefield. The Rangers who crossed the Rhine in rubber boats demonstrated this principle through individual courage and collective determination. Their boats were technically adequate rather than superior. Their training emphasized practical effectiveness rather than theoretical perfection. Their tactics exploited American industrial advantages while minimizing exposure to German defensive strengths. This pragmatic combination proved more decisive than any single technical advantage could have achieved. The lesson resonated through post-war military development across all services. Technical sophistication alone could not overcome the combined effects of industrial capacity, tactical flexibility, and operational momentum. What German defenders had initially dismissed as flimsy rubber boats ultimately outmaneuvered their concrete fortifications through unexpected technical resilience and tactical innovation. The Rangers accomplished in minutes what conventional doctrine claimed would require hours. In doing so, they demonstrated how seemingly minor technical modifications could produce strategic effects when combined with tactical flexibility and industrial capacity. Their achievement stands as testimony to the enduring military principle that victory often depends less on absolute technical superiority than on effectively applying available capabilities through operational art. The rubber boats that crossed the Rhine in 15 minutes represented not just a tactical innovation, but a fundamental approach to warfare that helped secure Allied victory in Europe. As we reflect on their accomplishment, we recognize that military history often focuses on dramatic technological breakthroughs, while overlooking the incremental improvements that collectively transform operational possibilities. The Rangers' rubber boat revolution occurred without fanfare, despite its strategic impact. Their legacy reminds us that decisive innovation often emerges from practical problem-solving rather than theoretical brilliance. Their story demonstrates how courage, adaptability, and technical ingenuity combine to overcome seemingly insurmountable obstacles. The soldiers who paddled across German machine gun fire in reinforced rubber boats deserve recognition not just for their physical bravery, but for their intellectual flexibility in adapting equipment and tactics to operational requirements. Their example continues inspiring military professionals to seek practical solutions rather than perfect technologies. The relationship between technical capability and operational art they demonstrated remains relevant across technological generations. Their achievement reminds us that human ingenuity often matters more than technical sophistication in determining battlefield outcomes. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.